Hi everybody, in this video we're going to talk about how we can convert a quadratic function that's in standard form to vertex form. And the reason we want to do that is so that we can identify any transformations that have been applied to the parent function to create this new function, and also it's going to help us really easily identify the location of the vertex of that parabola. So the first thing that we always want to do is we want to take our quadratic function that we have, and we want to start by grouping our x squared and x terms like this, just putting some parentheses around them. What we're trying to do is we're trying to take what's in the parentheses and we're trying to turn it into a perfect square trinomial. It's a special type of trinomial, meaning just three terms that will factor into two of the same factors, letting us write it as whatever that factor is squared. So in order to do that, you'll notice I have the -2 here underlined. In order to turn this into a perfect square trinomial, we first need to get rid of this -2 that's in front of x squared. And I don't mean just erase it. To get rid of it, we need to really factor it out of our grouping here. So let's start by factoring a -2 out. And when I factor the -2 out, it goes in front of the parentheses, and we're going to go back and divide everything that was in the original grouping by -2. So -2x squared divided by -2 is just x squared. 8x divided by -2 would leave us with a -4x. And my -10 is still out here. It's not part of that grouping, so factoring a -2 out is not changing that value at all. Now, the next thing that we need to do is, remember we're trying to create a perfect square trinomial, we need to add a c value in here. So we need to do some side work. To get the c value that will turn this into a perfect square trinomial, we need to take our b value of -4 divided by 2 and square it. Okay, in general, you're taking b divided by 2 squared. In this case, our b value is -4, so I substituted it into our little formula here. So if we simplify, -4 divided by 2 is -2, and if I square that, we get +4. So we need to take this value, okay, this is an important value. We're going to take this and we're going to add it inside of our parentheses, and it's going to create a perfect square trinomial for us. So let's go ahead and do that. Now, nothing else is going to change just yet. We still have -2 out front, x squared minus 4x. Okay, we're adding our 4. But here's the problem. Since the beginning of time working with equations, we've never been allowed to just add a number to equation and call it a day. We always talk about how we have to keep our equations balanced. Whatever we do to one side, we have to do to the other. So our balancing strategy is this. If I'm adding 4 in here, I need to do something out here that's going to balance it out. Here's the problem though. Because I have this -2 that's multiplying all of these values inside, this isn't really just a +4. This is really a -8. And I know it says +4 here, but if we take into consideration the -2 out here that's multiplying it, it's really a -8. So to balance a -8 out, we need a +8 out here. So the idea is, if I were to stop right now, distribute the -2 to everything inside the parentheses, and then combine like terms, the -8 and the 8 would cancel each other out, and everything else that would be left would be what we started with up here, okay? Meaning we're not changing the value of the equation, we're just basically reorganizing and restructuring the way that it looks. So let's continue here. Let's rewrite it, clean it up a little bit. We've got -2 times x squared minus 4x plus 4. Okay. -10 plus 8 leaves us with a -2 outside. Now, the very last step is we need to go ahead and factor this. And remember, we created this perfect square trinomial, so when it factors, it should factor into two identical factors. So remember, you're thinking what two numbers multiply to +4, the c value, and add to -4, our b value. Well, -2 times -2 gives us +4. -2 plus -4, or I'm sorry, -2 plus -2 gives us -4. So our two factors are x minus 2 and x minus 2. Now, since I have two of those, when we actually write our final form here for the vertex form, we're going to write this as -2 times x minus 2 squared. And then we have our -2 or -2 at the end. So this is our function in vertex form. It started in standard form. This is vertex form. And the reason we like this is because it lets us identify the vertex really quickly. Okay, looking at the transformations that have been applied, okay, the -2 inside tells me that it was shifted or translated right 2 units. And the -2 at the end tells me that it was translated down 2 units. So here is where my vertex is.